Hey everyone, Mr. Armitage here. In this video, we're continuing the series of the Check Your Understandings and reviewing them, so you can check your understanding. Okay, this one comes from the assignment on March 11th. Okay, what's the proportion of orange Reese's Pieces? And if you did well, right, you got the actual Reese's Pieces on the 12th. Okay, so going to our check your understanding, right? The sampling distribution of p hat. So the sampling distribution of sample proportions. Okay. So according to the American Dental Association, 8% of adults have never had a cavity. A dental graduate student contacts a simple random sample, an SRS, of 900 adults and calculates the proportion, p hat, in this sample who have never had a cavity. Okay. Identify the mean of the sampling distribution, p hat. Now, if we remember, our mean of the sampling distribution, p hat, is simply equal to the proportion, okay, which in this case is going to be the 8%. That's all there is to it, right? In the important ideas, right, you had this exact note. You had this exact statement in there. Okay? Always check the important ideas, right? Because that's an important idea. Surprise. Calculate and interpret the standard deviation of the sampling distribution of p hat. Check that the 10% condition is met. Okay, so let's do the first part. Calculate and interpret the standard deviation. Okay. So our standard deviation, okay, this was also in the important ideas. P times 1 minus p divided by n and all square rooted. Okay, so gonna plug in 0.08 times 1 minus 0.08 divided by our sample size, n, which is 900. Okay, I got to toss that into a calculator real quick. 0.08 times 0.92 divided by 900. Okay. And so we get 0.00. I'm going to go 904. Okay. For the fun of it. Why not? Okay. So interpret this, right? So if we look at our sentence frame, which is what I'm doing right now, right? Okay. So the actual percent of adults, or percentage, who have never had a cavity is typically, sorry, not, ooh, right. So actually, I take that back. We shouldn't say the actual percentage, right? We should say the sample proportion, okay? Because that's what we're dealing with, okay? We're dealing with sample proportions, okay? We're not dealing with actual like individuals here. So the sample proportion of adults who have never had a cavity is typically, right, 0.009 away from the mean, from the true proportion, right, the mean, of 0.08. There we go. Okay. Now, as for the 10% condition, right, verifying that that's met, okay, well, we're really asking the question then, is 900 less than 10% of all adults in the US? Okay, right? We don't have to calculate anything. Okay, sometimes it's just, I don't like using the phrase common sense, but sometimes we just think about it a little bit, right? There are a lot of adults in the United States, okay? And so 10% of a lot is still a whole lot. So 900, yeah, that's going to be less. Okay. Okay. Yeah, less than 10%. Okay. So now, is it approximately normal? So we are checking the large counts condition. Okay. So the large counts, remember, n times p should be at least 10, right? Expected number of successes. And also n times 1 minus p. The expected number of failures should be at least 10. Well, n is fairly straightforward. P, right, the proportion. So we have 900 times 0.08, and we get 72. Okay. Now 72 is indeed bigger than 10, so we're good there. Okay, now let's check here, 900. Let's move it up a bit. 900 times 0.92, right? 1 minus 0.08 is 0.92. And we get 828, bigger than 10. Which is also true. So there we go. So yes, it is approximately normal, which means we can use the normal distribution in this problem. Good, 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 good. Okay. So now we want to find this probability. Okay, find the probability that the random sample of 900 adults will give a result within 2 percentage points, plus or minus 2 percentage points of the true value. So we have to set up our normal distribution. So the true value, right, 0.08 is in the center there. Okay, well, plus or minus 2, right? So we're saying 8, well, 2 percentage points below that would be 6, and 2 percentage points above that would be 10. Okay, so we're looking at 0.6, 0.10, and this area in here. Okay, so there we go, right? This is a normal distribution with a mean 0.08 and a standard deviation 0.00904. Okay, so we can go ahead and plop this into normal CDF. Okay. Lower, it's going to be 0.06, right, because that's on the left side of our boundary. Upper, okay, that's going to be 0.10. That's on the right side of our boundary. The mean, it is our mean, and the standard deviation is the one that we found. Now when we toss that into our calculator, right, using normal CDF, we get approximately 0.9731. Okay, so accidental zoom in. So about 97.31%. Great. Okay. Okay, so there you go. Last question. If the sample size were 8,100 rather than 900, how would this change the sampling distribution of p hat? Okay. Well, if we check it, okay, shape is going to stay the same. Mean is going to stay the same. Okay. The only thing that changes with sample size is the standard deviation. Right? So the new standard deviation would be out divided by, right, 8,100. Okay. And we would see that this would give us 0.00301. Okay, close enough. Well, I'm going to do 4 there. Okay. Now, the thing to notice, right? Let's look at these two standard deviations. Okay. Let's look at this one. Okay, the one we just calculated versus, right, the one we got earlier. Okay, they're different. Yeah, but different how? Okay. Well, let's check it. Okay. 0.009 roughly divided by 0.003, okay, 3. Okay. So how would this change? The standard deviation would be 1/3 of what it is, of what it would be. Value for n equals 900. Okay, and there's a very specific reason. Okay, and I'm not going to go super deep into the math for it, so if you want, you can just end the video now. You're good. If you want to know why, right, we have a square root here. Okay, 900 times 9 is 8,100. Okay, now we're technically taking a square root over the whole thing, right? So square root of 9 is 3, okay, and that's where the 3 comes from. Okay? In order to have our standard deviation, we have to double it. Well, we have to multiply by 4. Okay? In order to make our standard deviation 1/3 of what it is normally, we have to use a sample size that's 9 times greater. Don't worry, that'll come up again later on. But in the meantime, have a great day.